And we're live. Welcome, everybody, to another episode of MongoDB Podcast Live, coming to you live from just outside Philadelphia, Pennsylvania. Today, we're going to be talking about fraud and solutions to fraud in the financial services arena. Welcome to the stream. I see folks piling in. Let us know where you're joining us from. I always like to find out who's joining from the farthest location from myself. I'm on the East Coast of the United States, and love to find out where you're joining from and what your interest in fraud detection, fraud prevention is. We're going to be focusing on fraud prevention with Databricks. We've got some experts in the field. We're going to have a great in-depth discussion. We're going to show some diagrams and get into some technical details. So I hope you're ready for that. Get your questions ready. If you've got questions for experts in this space, in the financial services industry, around MongoDB, around Databricks, around fraud prevention, get those ready and have them available as we bring our guests in. So thanks for joining. Liva from Finland, welcome. From France, from Serbia, from California. Andy, what's up? Great to have you joining us. All right, let's get into the show. Without further ado, I'm going to bring my guests in, Shiv Pullepu and Ricardo Portilla. It's great to have you on the show. Why don't you let the folks know who you are? Let's begin with you, Ricardo.
Sure, yeah. Thanks very much, Michael. So I'm Ricardo Portilla. I'm a financial services technical lead at Databricks. And fraud is very familiar to me. I actually spent a lot of time before Databricks at FINRA, which is a financial regulator here in the US that regulates the financial markets. And so spent a lot of time with cloud solutions on things like front running and spoofing and things like that. But really happy to be here. Thank you.
Fantastic. It's great to have you on the show. And Shiv, my friend from MongoDB, let folks know who you are and what you do.
Sure. Yeah. Hello, everyone. My name is Shiv Pullepu. I'm a principal financial services industry here at MongoDB. Before joining MongoDB, I worked in the banks and financial institutions for a number of years. And in regards to fraud, I have actually experienced building out solutions around anti-money laundering, KYC, and other risk management platforms in the past. And I have never committed any fraud, but I prevented it. I tried to prevent it. Okay, thank you, guys. And that's it for now.
I'm glad to know that you haven't committed any fraud. That should be one of the things that we look for in the hiring process, I suppose. But so we're talking about fraud prevention today, specifically in the financial services arena, and both of you have experience in this space. I'm curious, maybe Ricardo, talk a little bit about where Databricks fits in the fraud prevention space.
Yeah, absolutely. So, from I think kind of what's been trending and what's been really important over the past few years, especially for fraud, is there's just so many different flavors, right? There's application fraud, account takeover. There's a lot of things like check fraud on the rise. And so when you start to think about all these different types of fraud, I think there's two things that underpin fraud solutions. There's real-time capabilities, and then there's machine learning and AI capabilities as well. So I think both those components are extremely important for developing not just things like transaction fraud, but even preventative fraud, right? Knowing ahead of time, how do we detect fraud and how do we leverage real-time processing and systems, and how do we leverage AI as well? So I think, talking about Mongo plus Databricks, there's such a great story around making the application real-time, but also bringing the intelligence in, which Shiv is going to cover a lot. But those are two things that Databricks does really well, real-time and AI and machine learning. So those are just really important foundational components, essentially.
Yeah. Anything to add to that, Shiv?
No, actually, I want to expand on the real-time nature, right? So fraud requires real-time insights, right? Fraud prevention, because part of the reason is that the fraudsters or people who does fraud, their tactics or approaches, they constantly evolve pretty much in real time, which means you also need to have a tooling that would actually circumvent that type of fraud happening in the moment. So you need to have a solution to prevent that as it happens, not after it happened, right?
Mm-hmm.
So that is something we're going to expand on it.
Yeah, and I think that the key challenge is scale and volume, right? There's a massive volume of transactions happening, and to be able to insert logic in that flow of transactions efficiently and effectively is a key challenge. And today, if you're joining us, we're talking about fraud prevention. We've got some experts in the field. We're discussing that, so get your questions ready and stay tuned for a demo. So I understand, Shiv, you're gonna be showing what this solution kind of looks like. Is that correct?
Yes, yeah. We did an example solution around this using MongoDB and Databricks. I may not cover end-to-end demo, but I'll show
Yeah.
parts of the demo to save some time. But I do
Yeah.
have some links that attendees can actually use them and check this solution
Yeah.
leisurely at your convenience.
Okay, that's great. That's perfect. So we'll kind of do a verbal walkthrough of the demonstration. Now, Ricardo, you mentioned AI, and I want to dive into that. It's the topic of the day. How does Databricks implement AI, and is it a custom large language model or is it a custom implementation? What does that look like for Databricks?
Sure. Yeah, that's a great question, Michael. So I'll answer it. There's a few different. There's no one size fits all when we talk about AI. I think there's a lot of solutions where traditional machine learning is more appropriate. So if you're detecting things like spam, or you're trying to do simple forecasts on financial data, a lot of times traditional machine learning techniques will work out fine. And basically, Databricks kind of supports, as a platform, we support building your model in Databricks and notebooks and collaborative environments, and then deploying your model to an endpoint so that you can actually serve your model. But if we're talking about, this is kind of the age of Gen AI and LLMs, I think from the fraud perspective, it's really interesting. And there's some articles around banks like JP Morgan Chase and others who are starting to look at textual data, like emails is really low-hanging fruit. Other things AT&T is doing is basically scanning, texts for information and fraudulent activity as well. So that's, again, more along the preventative fraud. I think more AI techniques, especially LLMs, are being used more and more. And so we support building your own LLM model within Databricks. If you want to use something off of a hub like Hugging Face, you can bring that in as well. So it's pretty kind of, attuned to whatever you're dealing with, right? If you want to build your own, you can do that. If you want to use a large foundational model, you can use that as well.
Yeah. And where do you suggest that folks begin? I mean, let's say we're not using Databricks and we want to begin to look at ways that we can solve this problem, or at least begin to expose potentials for fraud.
Yeah, absolutely. That's a good question. And we've actually released a few what we call just solutions accelerators, which are templates for getting started in fraud. So for example, we have notebooks that show you, hey, if we start with just some raw transactional data, this is how you build a really simple model to detect the fraud. And here's how you can interpret the output, right? I think a huge part of fraud is the number of false positives. It's having some sort of interpretability on what the model's doing. So we actually have templates for doing that. But I would say more generally, even, aside from Databricks, if you're just trying to learn, there's tons of Medium articles on the different flavors of fraud detection, right? It kind of depends what you're looking for. And if you want to get started with LLMs, then, going to Hugging Face and looking at leaderboards and trying to figure out how to bring that into your environment, those are really good first steps too, just to get started more generally.
So I'm not familiar with Hugging Face. Can you give a brief overview of what Hugging Face is and what it provides?
Yeah, absolutely. So Hugging Face, for those that are new, it's a amazing hub of models, code, templates, different transformers, and basically kind of almost GitHub for all of your LLM models and Gen AI models, so that you can go there and more easily get started, right, with quick starts and different ways to actually serve your models for a lot of the LLM techniques out there today. So if you go to Hugging Face, it's kind of, you can think of it as almost wrapping around this enormous world of NLP models and things like that. So it's extensively used. Like I said, there's a leaderboard for a lot of these models, so you can figure out which ones are most downloaded, what is the license on these things, can you actually use them for commercial use. So they have all of this documentation for the models themselves, as well as the models and things like that. So it's a great repository to kind of go and get started there.
Fantastic. And so Shiv, MongoDB and Databricks work well together. Do you want to talk a little bit about how they come together and what that integration looks like?
Sure, yeah. MongoDB, it has a lot of native connectors to actually send data to and from Databricks. Like one of that is Apache Spark connector. There saves a lot of developer productivity, like developer development time, because it's out of the box and you can drag and drop, and you just specify your connection string to actually ingest data back and forth. That's one way to integrate these two amazing platforms. And the other option is to kind of use some functions like a dot out to actually write to maybe S3 a bucket or something, Parquet files, Databricks friendly file format, to able to kind of prevent fraud. Like I was saying previously, like MongoDB, as you know, Michael, is an operational data platform, and they're sending this live transactional data via these integration paths out to Databricks to both train, retrain a model, pretty much like maybe at a predefined interval of time, and fine tune, retrain the models, and also classify a particular transaction, whether it's a fraudulent or not. You can do that in real time. So it helps kind of build that real-time integration capabilities, right, to prevent a fraud.
Yeah. Well, I'm still curious, and I'm trying to visualize it. I wonder if there's something that we can show the viewers.
Sure.
Something we can demonstrate or show.
Let me actually share my screen here. Start from the beginning.
Okay, so while Shiv is getting ready, if you're joining us, we're talking about fraud detection and fraud prevention with Databricks and MongoDB Atlas. If you've got questions, get them ready. You can put them in the comments and we'll try to get to them. If I see a comment or a question, I'll star it so we can come back to it if we're not at that point yet. So there we go.
I hope you see my screen now.
There we go.
Wonderful. Okay, let me start from the beginning here. Do you see my first welcome screen, guys?
Yep, we see it.
So we talked about, we already introduced, so I'm going to skip this slide. So embedding AI into applications, right? This is what we have been talking. This helps in preventing fraud or even to address a number of business challenges. Initially, if you think about evolution of AI or intelligent application development, and you see in the beginning, right, intelligent apps used a basic analytics, like previously Ricardo was saying. Basic analytics meaning min, max, and some aggregate functions and things of that nature. But as the computing power grew, the focus shifted to historical data, like deriving these deep insights using some historical data. That's where we used tremendously artificial intelligence and AI models, right? And we call that as a traditional batch ML, right? And today we are actually enhancing those AI ML models with real-time data. So in other words, we are operationalizing those ML models, and we call that real-time AI, right? Real-time machine learning. And also, if you think about, like, since last year, November, and a lot of focus is shifted towards generative AI. So all these approaches actually help prevent a fraud or even address a number of business challenges. Let me go to the next slide here. And for this reason, a lot of these companies are actually trying to become a AI, data plus AI companies. Maybe you want to talk about this a bit, Ricardo?
Sure. Yeah, absolutely. So I mentioned at the beginning, I think the two best things that you can kind of run on Databricks are, streaming and real-time capabilities, and then also AI and building LLM applications, things like that. So I think these are three just really good examples of companies that have taken the data, they've kind of curated it in the same way that OpenAI, took a massive data set and leveraged it for its power, right? So for ABN AMRO, basically, a lot of what they were doing, this is a Dutch bank, was getting all the data across all of the different financial services providers. So not just ABN AMRO's banking and transaction data, but data from the whole ecosystem, so that you as a user for personal finance apps and things like that have an aggregate view of your finances, right? So they did this really well. ABN AMRO also has some really great YouTube videos on how they detect, or they run their AML, their anti-money laundering program, and things like that. So really good fraud examples. S&P Global, I think we all know them as a data provider. They kind of monetize their ESG data with a workbench and essentially cover, I think, around 20,000 companies, representing this 98% of global market cap. And again, just a great way to take, highly unstructured data, textual data, and things like that, and then actually convert it to insights. So those are just kind of a couple examples of the AI embedded.
Thank you, Ricardo. But unfortunately, if you look at it, not every organization is able to bring AI to their applications. A reason for that is a couple of reasons for that. Actually, as you can see on this slide, there's a clear separation of domains within banks. Like especially, I worked in banks, like I said previously, a number of years, and there is a divide. There's a gap or a bridge, right, that we need to fill. Like there is a centralized analytics teams. They sit in one corner, and there is a development teams. There is that siloed nature actually cause a lot of inefficiencies in the way they bring the data, right? They'll have to use a lot of these ETL jobs to actually get this all these operational data to a centralized data warehouse, and it takes time, and you may not be able to do fraud prevention in the moment in real time. So that's one challenge. And the other challenge is that they use organizations use a mixture of technologies, like number of legacy technologies, on-prem, cloud, and integrating those on-prem and cloud is not that easy, as you know, right? And having too many technologies, right? Kind of like you have like data silos, and they end up spending a lot of time in creating a comprehensive view of a customer. Say, for example, in fraud prevention, if you have more than one channels actually taking or ingesting a transactional data, creating like the comprehensive view or a holistic view of that customer may take a while, right? Because the data need to be actually aggregated in one central location through ETL jobs or maybe overnight batch jobs. So there is that challenge, and the technical sprawl actually also causes a lot of challenges because you'll have to spend a lot of time in both in terms of ongoing maintenance, administrative cost, and also bringing developers to manage those many technologies is a pain in the neck. So those two challenges I wanted to call out primarily why all these organizations are not able to actually efficiently bring intelligence to their applications. Maybe those are the two bottlenecks. And we're going to talk, myself and Ricardo, we're going to talk about how MongoDB and Databricks can help actually resolve or circumvent those problems, and help bring a real-time help create a real-time event-driven systems to prevent fraud. So let me actually take a quick, maybe 30 seconds to give you a quick primer on MongoDB. So MongoDB it has a number of features. I'm not going to go cover all these features out there, but features that are primarily useful for financial services. So one of that is a document model, which is a flexible document model, and kind of help ingest any type of a workload, like for example, relationships or geospatial data or time series. Geospatial data is especially useful for fraud prevention. You can actually use like an IP address or a geolocation to kind of help or flag a transaction, whether it's a fraudulent or not. For example, if a transaction is actually is coming from originating from China for a cardholder, US cardholder, you can actually flag that there may be some problem with this particular transaction. So, and also it comes with a lot of robust data management features that especially data federation is one thing, and also a lot of native connectors to help synchronize data across different platforms, including Databricks. And it's not a data persistence layer. It is actually a developer data platform, which means comes with all that tooling necessary to kind of build a number of application services like search and analytics is one among them. And this runs on the multi-cloud, Google Cloud, and AWS and Azure. This is particularly important for financial services where you are by regulations you are not you are required to actually segregate your or put your workloads on different hyperscalers, not just one hyperscaler, right? Otherwise there is a cloud concentration risk. So there are a number of other features, and the Databricks, and Ricardo, I'll let you introduce Databricks maybe.
Sure. Yeah, absolutely. And yeah, just to echo that multi-cloud sentiment you were getting into, Shiv, I think that's just so critical, right? From just diversification, being able to handle things like DR across clouds in some cases, but Databricks, deploys on all three clouds as well. Just to take a step back before kind of getting too heavy in this, where Databricks started over a decade ago was really trying to figure out for the FAANG companies like Uber, companies like Apple that actually had access to large numbers of engineers to go and deploy Spark and deliver these amazing AI solutions and things like that. We wanted to democratize that to everyone, right? To every enterprise. And so where we started was creating Apache Spark for, multi-purpose data processing. And where we evolved to today is basically doing that across other things like governance, being able to support data warehousing workloads. So that's kind of what you're seeing now with this Lakehouse platform. We are the Lakehouse companies. All that means is really we support everything from the data processing to real time to data science and machine learning. And all of that is kind of underpinned by governance in the data lake. We are built on the data lake, and then we're multi-cloud here that you can see. So from the financial services perspective, that governance layer and having control of your sensitive data, PII, PCI, and things like that, really important for fraud. And that's an area where we've invested really heavily as well.
Wonderful, thank you.
So before you begin, I want to make something clear. Like I really resonated, the slide that you put up before, Shiv, about the technology sprawl and all of those different technologies. This is very common. I come from a financial services background myself. I was at a large, top 50 bank, and this is just a fraction of the number of technologies that we had. So what we're essentially saying is that with the depth and breadth of functionality in these two platforms together, we're essentially suggesting that this is a modernization play as well. Is that correct?
No, yeah, exactly. So the one reason, like I said previously, Michael, organizations have failed to bring AI is because they deal with too many technologies to actually do one simple or to address one simple challenge. Not simple challenge, a challenge like a fraud, right? Part of the reason is the legacy technologies, right? They may not be able to actually do search and analytics out of the box. I mean, you'll have to end up bringing some type of a niche technologies to kind of complement what these relational database management systems provide out of the box, right? And also they may not have these rich mobile features like the synchronization features are particularly important to kind of activate any type of observations that you make around a transaction in the moment in real time to a consumer. So for mobile, they bring another niche technology, right? So it becomes like a spaghetti kind of a technology, a sprawl issue, right? In the development team spend a lot of time in actually kind of managing these individual technologies, and that actually cause a lot of they put a lot of strain on the platforms as well. So really having a platform like MongoDB kind of help alleviate all those challenges, because out of the box you have all these necessary tooling like in one platform, right? So that helps with the developer productivity and the low TCO and the faster time to market. Like even like I was saying previously, fraud is a constantly evolves and changes, and to actually address constant fraudulent activity, you may need to apply a new change to your existing infrastructure, right? Changing something on a relational or another legacy, it may take a while, but in the MongoDB world, you can actually bring these changes without actually any type of a downtime, right? So there's not a lot MongoDB can do. Like there are basic analytics that you can do, but for advanced analytics, obviously you need some platform like Databricks, right? Like MongoDB. Databricks also is a platform, kind of provides that end-to-end AI ML pipeline and the features, right? And also this is one thing I like about Databricks is and the MongoDB is both are open source based, and there is a lot of community support behind it. And so what with the two technologies, right? My point is like two technologies that work really well, you can actually address a number of business challenges, including fraud. Do you want to add anything, Ricardo?
Yeah, the only thing I would add is, again, kind of on the fraud theme, that high availability that you get from Mongo and having all the different types of data, right? In the document model, you had basically time series, geospatial, you're going to have textual data. I think the idea that you can basically develop everything there and then kind of call the services from Databricks when you need them for that intelligence, it's just a nice, seamless experience. So I think it's a really good way to use the combination of the two technologies. So I just want to call that the specific data types for fraud that I think are critical.
No, yeah, that's a brilliant point. The document model actually provides a flexibility as a feature sets and the model requirements has changed, especially in the generative AI space, right? The number of parameters that you use and the type of data sets that you use and these requirements like they constantly change, are complex in nature. So document model is so flexible that can actually you can use it to model structured, unstructured, any type of form and shape. So thank you, Ricardo. So when we talk about integrating these two platforms, right? Like I mentioned previously, there is a native connector, like the one thing that you see Apache Spark connector. You could actually use this connector to both structured streaming and a micro batch. This is something that we have used in our example solution that I'm going to spend a few minutes there. And there are other integration paths that you can take here. One of that is a batch route. There is a function .out function that that I mentioned briefly. You can actually write a data set or a subset of data that you wanted to use to actually train or make observations using AIML on Databricks, and you can actually write that out to a S3 bucket or some other medium in a Parquet format. And there is a Kafka streaming as well option available to kind of integrate these two environments. So why are we talking about fraud? Fraud in the financial services is, right, we talk, like Ricardo mentioned previously, can take any form and shape, right? And identity theft or account takeover is a big challenge. A Ponzi scheme, I don't know if there is any type of technical solution we can actually come with to prevent a Ponzi scheme, but there is another one like money laundering, anti-money laundering, and organizations, right? Collectively, they're losing 28.58 billion. This is stats based on Nielsen report in 2020, right? There's a lot of 28.58 billion is a lot of money, and if you look at like a recent, like previous year statistics, and the financial loss actually reached 32.34 billion, which is like I think 15% increase from 2020. So obviously, based on the uptick or in the amount of loss, I mean, we can clearly see a lot of financial services firms and banks are struggling to prevent fraud, right? And why are they struggling? Why card fraud is so hard? Like we said previously, it's a broad and dynamic because the attack surface is too wide. The attacker can actually come in and kind of intrude your account or take over your account from any channel or any type of web or mobile or even device type attacks can happen. And the other challenge is data silos because of this may be a side effect of having too many technologies, right? And the third important thing is the costly to manage a mixture of technologies. Like I said, you have like a legacy rules-based models, and also you may have some AI ML tooling, and it is costly to manage the development teams and also the infrastructure at the same time. So I want to take a pause here. Ricardo, do you want anything before I get into the solution part?
No, the only thing is that for that broad and dynamic point, the first point you made, I think that's just so critical, right? There's hundreds of different flavors, and you don't know what you don't know. So unless you're using AI to actually go and find new instances of fraud and using unsupervised learning, then you're at a disadvantage, right? And we're seeing there's a huge uptick of fraud, almost 2x what it was 2 years ago. So I think that's a great point. And I think these, again, using the two technologies allows you to not only move quicker, but find all those new instances as well. So
yeah, I don't want to slow this down, because I'm really enjoying the flow of things, and I want to get to where we show some walk through that demo. But like, why is the explosion of fraud? Is it just more people attempting?
Two reasons. I'll take that. So there is a tsunami of payments, right? Especially post-COVID, Michael, and folks stopped going to banks, and they're doing all these transactions online, right? I remember going to my local regional bank to do any type of money transfers, or even to send some money out to my family in India. I used to use wire transfers and all that. But these days, like, there are a number of digital channels and real-time payment systems actually helping send payments, right? And the payment volume increased significantly. Volume is another reason, right? So with that, like, there comes actually the challenges with like the existing infrastructure may not be able to scale appropriately at the rate of growth, right? Growth in the volume. And the other reason is the type of payments, right? You have different types of payments, like ACH payments, and the FedWire, and the real-time payments, and the check payments. Like this, one of the area, like fraudsters actually kind of like gain a lot of advantage, and I stopped using any check payments, right? So the payment rails is a payment rails, or a payment method, is one reason, and the volume, and also the fraudsters actually, they are also developers, right? They actually learn these new techniques, like a generative AI, or maybe whatever you call, like all these latest techniques, to kind of find a way to kind of and do some fraudulent activity. So it's a constant battle. Do you want to add anything, Ricardo, there?
Yeah, no, I'll just add. Yeah, fully agree. I think there's post-COVID, there's been an explosion of just more online, payments and channels and things that people use. But the other thing is, I think there's a lot of social engineering attacks, which have also sprung up, right? Especially if you think about Gen AI and LLMs, fraudsters can use those tools to their advantage as well. So that's why I think there's a lot of attention to all that, just, natural language data, text, emails, things like that. So that's just another avenue for fraud.
Okay, so how do we actually address this challenge, right? If you think about it, or if you have worked in any fraud prevention solution building in the past, right? You typically see there are three actually stages in the preventing a fraud, right? The one is usually they do try to prevent fraud based on some rules engines, right? Maybe they are specific to an organization, accustomed to an organization, and then beyond the rules based prevention, you leverage AI ML based detection. That's where Databricks come into play here to help support that AI power to fraud prevention. And then the third stage is case management. So when you talk about like rules-based management, MongoDB has a number of features, like I mentioned here on this slide. There are Realm rules services, and we have aggregation pipeline to help program or codify these rules into an actionable or a code that can actually prevent that you can actually execute to prevent or flag these transactions. And once you have these flag these transactions, and you can use MongoDB application services like change streams to kind of activate these observations that you made against the different channels like a mobile and web here. That's how you do. And rules-based, this is where you could actually use some streaming technologies, for example, a fraudster or a legitimate a payer trying to pay to a merchant, like on a mobile device or a web channel. You could use a streaming services like Kafka to stream the data in real time to something like a MongoDB. And MongoDB, like I said, you can use the change streams and other under triggers to kind of call out an external endpoint, AML endpoint, which is hosted on a Databricks environment to kind of classify, well, this incoming transaction is a fraudulent or not. So if the AML models, this can be a generative AI or more any type of AI model that you use, maybe some geo-clustering type models that you can use to prevent fraud, right? So once that observations are made, you can actually bring those observations back to MongoDB using this Apache Spark connector. Like I said previously, there is a tight connection between Databricks and MongoDB. That helps ingest those observations in real time, almost in the moment, and that helps with customer communication. And the third stage, what you do is, like, once you have made those observations, you can actually help prevent fraud by actually sending those observations to both your consumers. Saying, well, you typically see, like, when there is a fraudulent transaction, you may see a SMS alert on your mobile phones. I know maybe some of you may have seen that. You need to say yes or no. If you say no, they actually, banks usually, they block the transaction. If you say yes, they actually clear the transaction. There is that customer side case management, and also internally in the banks, they actually manage these fraudulent transactions, right? And directly work with the customer. So MongoDB comes with those features, like the mobile features, and also a number of other features that you can leverage to kind of connect the kind of provide the end-to-end tooling in the fraud prevention. So if you put all these pieces together that I discussed previously, all those three stages, right? It forms a nice, but a simple and elegant event-driven architecture, right? In that you have a fraud rules-based fraud prevention, which is done on top of a MongoDB, and you could do actually fraud detection using the AML, and which is generally done on AML platform like Databricks here, and then the observations that these tools make can be activated against these channels like case management and also web and mobile. I'm going to take a pause here. Michael or Ricardo, do you have any questions, or maybe you want to add something here?
Yeah, I'll just call out, I think this is a really helpful architecture just to understand the end-to-end picture. And there's actually, there's two different design patterns, I would say, that are kind of lurking here. One of them is the ability to connect to MongoDB and then, pull out some data, build the model, which you see in the lower left-hand side of the red box. That's more of a, batch, let's grab historical data, go build the model, and then start to basically manage that model, promote it to different environments. That's more of an offline, flow. Whereas I think the other thing that's highlighted here is the actual fraud detection in the green box, which is, real time, high availability. You can, stream those predictions. You can just call the REST API model serving endpoint, things like that from Databricks. So just want to call out, I think having those two as part of this ecosystem is really helpful, right? Because you can easily connect to Mongo, pull incremental changes, and then you can also call the REST APIs from the MongoDB application. So two nice integration points there I just wanted to call out.
Absolutely. Great points. Yeah. yeah, there's that inline integration I love about. You can call Databricks API from within your application code, which is really beautiful.
Yeah.
So
demo.
so I'm not going to actually spend a lot of time on the demo. We have a recording. Guys, I'll leave that recording with you guys, and please take a look. But in the demo, right, I want to call out 3 important personas or actors that we used. Like the one is a client. In this case, the client is any person with a mobile device or a web device trying to pay payment to a merchant, and the MongoDB is a platform where you persist all these transactions, and also call out a Databricks endpoint or a YAML endpoint inline, right? The three participants here, like I said, like the 2 technologies. We use just 2 technologies, not more than 2 technologies. No technical sprawl here, and both are platforms and come with all that tooling necessary to create an elegant event-driven architecture for preventing fraud, or even to actually create any type of intraday risk management type solutions in-house. And also in this example, we actually used MongoDB as a feature store. Some of you are familiar with AIML or have done AIML in the past. You end up spending a lot of time in finding these features, right? And the sharing those features across the organization kind of improves reusability, or actually help sharing these features with other departments, right? So using a platform like MongoDB to kind of persist those features, you can actually help share those across the organization. So we used MongoDB as a feature store in this example. So I'm going to actually show some functional screenshots here. So when you download this demo, which we have actually put up on our GitHub repository, when you log in, once you provide your user ID password, you land onto this dashboard or this home page. And in the home page, there is a transactions tab or a button that when you click on it, you can actually initiate a transaction. And here, when you click on a profile screen is where you can actually define some rules-based rules to kind of prevent the transactions, right? For example, as a payer or as an account holder, right? I wanted to prevent a transaction beyond a certain dollar amount, right? So I can actually define those rules, right? One is the dollar amount. Maybe a second thing can be like number of transactions in a day. Things like that you can actually define. And this program that I was talking previously can actually look into those rules to kind of block those transactions not meeting those threshold limits. So a successful transaction when it meets all these rules, and also there is no fraudulent activity, or the AIML platform that you see here in the middle, if it classifies this particular transaction as a legitimate transaction, and this is what you would see. This is a successful payment transaction, a flow, or a user experience that you see. This is a typical rejected payment. For some reason, if this fraudulent fraud detection processor that we built out, an example solution, if it classifies the transaction as a fraudulent, this is what you would see, a rejected payment. So I'm going to quickly show this recording. Parts of the recording. I'm not going to show the complete demo. This is what I was saying previously. You provide your user ID login, and you can go into landing screen. And let's say if I want to pay to a merchant, I pick a merchant here and then enter a reasonable amount here, which is under my threshold or the limits that I predefined. And this is a successful payment transaction flow, and this payment is authorized. And similarly, if you do, or a fraudster does a fraudulent activity, they'll see a rejected payment um, experience that I showed you previously. So to actually come up with a solution, like we did a very simple a collection view. I'm not going to go into this, but this one collection we used to kind of define all these user level or payer level limits, transaction limits, and the number of transactions per day. And also this is incoming transaction. There is another collection used for incoming transactions. And this is the features that I was talking previously. When you have a raw transaction, Databricks actually does its job to kind of create these features relevant for preventing a fraud, and we used MongoDB to persist those features within MongoDB. From the Databricks side, we used two workflows, one for training and the other for actually streaming live transactions from MongoDB as the transaction happens, and this streaming job helps actually classify a transaction, right, whether it's fraudulent or not. So this is there are three stages in the training workflow. The stage one's model training, and the and registration. I'm not going to go over this, but you can actually, as I said, like leisurely, you can look into that. This is a feature store, like when you have like a raw transaction, and on the Databricks side, we have used XGB model to kind of prevent fraud as an open source model. But you can use a model of your choice. And this is a feature generation screen, how this platform actually helps generate these features, and we use those features, and we send those features back to MongoDB and store them in MongoDB. And then let me go to yeah. So once we have this an endpoint, right? You can actually productionize an endpoint or move an endpoint to production and expose that as an API, right? And the other good thing about Databricks is you can actually create or manage the different versions of your model. This is particularly important when you from a regulatory standpoint of view, especially when you need to demonstrate a model observability, especially in the investment and asset and investment management firms, like they need to show these historical versions of our models, and you have that feature. And when you decide to promote a particular model of your choice, you can do that, and you can promote that. And you can test these models within MongoDB, within Databricks, like by sending a sample payload, right? And also, alternatively, you can actually test these models in a Postman type setting. Yeah, so
I would just add to that really quickly, Shiv. I think, that what you said about audit, right, and having the auditability, what was the payload, what was the prediction, is so important for financial services, especially if you're looking at, special investigations units and things like that for fraud. You want to have that lineage and observability there. So that's really key. And there's a lot of monitoring that we've introduced here for data drift and model drift as well. That's tied to this. So very useful.
Yep. So we so in this example solution, we have actually leveraged those versioning features extensively, because we had to actually run through different versions of the same model. We were not happy with the initial model, so when we kept on actually improving the model, accuracy, that came in really handy to keep a track of different versions that we used. Yeah, so the other good thing about Databricks is, like when you ingested the data or stream data from these live systems, like operational systems, right, or payment systems, you can see these the spike in volumes, right? Like this chart dashboard capability that you can see, so there is a sudden spike, right? And you see what the heck is happening here, and you may be able to actually kind of double click into that spikes and see if there is any bot attack or something, right? So it helps actually prevent fraud, even like visual observation, like in some situations. Yeah, so the demo shows like a live transaction. I have used a Postman to do or mirror a live transaction. This is a payload I sent to this endpoint in the $150 amount, and then I used this Postman to kind of do this demo. But you can actually take a look at this. We have a GitHub repo. This is what we were showing previously. Line number 10, if you focus here, this is where you can actually call a Databricks endpoint from within MongoDB, right? It's kind of like almost like you can bring your own AI ML model and plug it into MongoDB.
I love that. I love that because so it's a great way to kind of centralize your business logic. So this is in MongoDB Atlas App Services, and you're calling out from a function within App Services to Databricks. So that could be a way, and you could actually plug this in with a trigger. Am I right?
Correct. Exactly.
Yeah.
Exactly.
Mm-hmm.
And yeah, so when as the transaction happen, you pay, the transaction first lands in MongoDB. MongoDB has a trigger for insert for every transaction insert, and the trigger actually invokes a function here, like you see here, right? The function actually takes the payload from MongoDB, and the payload is sent to Databricks, and Databricks does its job, right? And clean up the transaction payload and create these features, and then help you classify this transaction whether it's a fraudulent or not. All that is done in the moment in real time, and you get an observation back from Databricks. This is a response, right? And you actually persist that response back in MongoDB. Once you have the data in MongoDB, you use MongoDB mobile features, Realm Sync, and other options to kind of share those observations in the moment with your both surface them on the device as well as share those with internal case management teams in dashboards and all that. So that's all like the end-to-end, right? You can do, like I said, you can do with the two technologies like MongoDB and Databricks.
Incredible.
And eliminate a lot of text crawling. Yeah.
Well, I just want to cover really quickly what you showed a whole lot there. And the link that I have on the screen, mdb.link/preventing-fraud-with-Databricks, is going to link you to an article that has links to the GitHub. If you've got an account in MongoDB Atlas and an account in Databricks, you can cobble that together and run this demo yourself.
Yeah, absolutely. I have those. Let me show you. I think it's there here. We have. This is something I liked. This guy, Anthony Jenkins, previously at a forum, he mentioned banks are becoming a museums of technology. This is an understatement actually to say there is a technical sprawl is a big challenge, or is a bottleneck in preventing fraud in real time. And the part of the reason why organizations are still struggling, right? Because there is a lot of tech debt or and the technical sprawl, and these organizations need to modernize into or to a more modern platform, not a niche technology, and use platforms like MongoDB and Databricks, a technology that works. I mean, there are a lot of people say that different technologies, not every technology people say works and really works in the real time, right? I have been there for a number of years, and I actually strongly recommend like picking a technology that works, like Databricks and MongoDB. So here we have all the resources that I showed you previously. There is a resource link here, and I did a white paper on fraud prevention, and then we covered this in depth. And also there is a GitHub. All these example solution and code samples are pushed to our GitHub. And there is a blog here, and the Databricks, Ricardo pasted some relevant links here in regards to AIML and how to integrate those with MongoDB. And if you're looking to actually modernize your fraud system or create a new fraud or a payment system, we are more than happy to help you, and we have a professional services. And if you're new to MongoDB and if you wanted to learn MongoDB, and we have a MongoDB University, which is free and open, and you can sign up to learn MongoDB 101.
Fantastic. Well, this has been a great discussion. I want to thank you both for talking today and sharing your experience around fraud prevention and detection with Databricks and MongoDB. Any final words, Ricardo, before we begin to wrap?
Yeah, I mean, I think we kind of opened with the diversity of the different types of fraud and kind of bringing the intelligence in the real time. So I think we covered a lot of the technical pieces of that, but I think the developer experience also was really amazing. That last piece that Shiv showed, right? Time to market and being able to make sure that you're not using 100 tools to detect fraud. I think this is such a great example of that, right? You can, there's no, again, one size fits all. It's not all going to be ML. It's not all going to be rules based. Even using that approach in Atlas and Mongo, you can actually combine the two, right? Rules based plus AI ML. So just wanted to highlight that. I think it's a great design pattern and just kind of really remarkable what these two technologies can do together alone.
Yeah, love it. Any final words, Shiv?
Yeah, like I said previously, I'm going to reiterate or echo the same statement. There are a number of technologies out there, and it's very confusing to pick a technology at times. But I would be smart to actually picking the right technology and the right number, right? A technology that works and the right number. Those are the two key aspects, right? In my experience, in my opinion, Databricks and MongoDB together can actually help prevent a number of challenges by bringing AI into applications.
Fantastic. Well, once again, thank you, Shiv. Thank you, Ricardo. It's been a great discussion. I will put the links up one more time. We've got, this one is going to be a key because it's going to link to all of those other areas. So before we end the stream, you want to jot that down, preventing fraud with Databricks. Thanks, gentlemen. Enjoy the rest of your day.
Thanks, everybody.
Thanks, everyone.